Factoring by grouping. So in this set, we are actually going to have 4 terms in our polynomials, and we're going to be breaking them apart into parts to look for things to group for factoring. Now, you can have more than 4 terms when you're doing factoring by grouping, but today, for our purposes today, we are going to be doing it in groups of 4. And so there are going to be 2 different parts, and we're going to look at the front and the back of this and see, is there something in common that we can see to pull out? So if I look at the first 2, and then I'm going to look at the last 2. So the first 2, what do they have in common? Well, they both have an x squared in them, so I can bring out an x squared. There is not a number that will divide into both 3 and 4 evenly, so I can't divide a number out. So I'm going to take 3x cubed and divide it by x squared. And that's going to leave me 3 divided by 1, 3. I have 3 x's, and I take out 2, leaves me just an x. Plus 4x squared. 4 divided by 1 is 4. I have 2 x's, and I bring out 2. That leaves me 0 x's left behind. On my second 2, I am going to be looking for a common factor. Well, there's not a variable in both of them, so I'm not going to be taking out any variables. My beginning sign is a negative, so I am going to be factoring out a negative. And a 5 will divide evenly into both those terms. So I'm going to take out a negative 5. So negative 15 divided by negative 5 is a positive 3. I did not change my x's, so that x stays the same. Negative 20 divided by negative 5 is a positive 4. Now at this point, we're going to look and see, do our parentheses match? And for these assignments, they will match if you did it correctly. And so they match, so I am going to be able to bring those out. And so that's going to be that 3x plus 4. Because they match, I brought it down. And then I am going to pretend like these do not exist and write down everything else that I saw. That would be the x squared minus 5. On this, I look at my last term of that squared binomial. If that last term is a perfect square, then I might be able to factor more. In this case, I can't. That is my final answer. Let's do another one. So I'm going to look at my first 2 and my last 2. So my first 2, what is a common number that can divide into both 12 and 14? A 2. How many x's can I pull out? Well, x squared is the least amount of x's. So 2 divided by 2 is 1, but I don't need to write 1. I can just leave that out. X cubed, and I take 2 x's out. That leaves me just an x. Now I go into the 14. 14, a positive 14 divided by 2 is a positive 7. I have x squared, and I take 2 x's out, and that leaves me no x's left behind. Now let's go to the second 2. In the second 2, my leading sign is a negative, so I know I have that. I look at the number in front of the x, and that's a 1 and a 7. What common number divides into both of those? A 1. Now, negative 1 divided by negative 1 is just 1, and I did not take any x's out, so you have an x. And negative 7 divided by 7 is 7. I chose to do an example like this because often people don't think about what to bring out in that second set, and that negative 1 can come out. And the other thing people do not think about is changing that sign here. And so they'll get to the next step and go, my parentheses do not match. Well, as they forgot those 2 pieces. So these 2 parentheses now match. I can write them down. Now write down my parenthesis once. X plus 7. I pretend like that doesn't exist. And I write down everything else. 2x squared minus 1. Can I take the square root of either of both those two pieces? And the answer is no. So that is my answer. One last one. Looking at my first two numbers and my last two. Is there a common factor in the first two? Well, they're both divisible by 4, and I have an x squared in both terms. 12 divided by 4 is 3. I have 3 x's, and I bring 2 out, leaving me just an x. 20 divided by 4 is 5, and it was a negative 20, so that makes that a negative 5. X squared, and I bring 2 out, means I have no x's left behind. In my second two, I start off with a negative, and I look at 27 and 45. They are both divisible by 9, so I'm going to bring a 9 out of both of them. 27, a negative 27 divided by negative 9 is a positive 3. I did not bring any x's out, so that x stays behind. Negative 45 divided by negative 9 is a positive 5. Oops, I made a mistake in my sign at the original problem. That's supposed to be a plus. Positive 45 divided by negative 9 is a negative 5. Now we have our common factor. These two parentheses match perfectly. So I need to write them down once. And that gives me 3x minus 5. I pretend like those do not exist, and I write down everything else. 4x squared minus 9. So there's no squares in that first parenthesis, so it gets left alone. Looking in your second parenthesis, we have that squared, and we have a minus sign. So can I take the square root of 4x squared? And that gives me a 2x. I can take the square root of 9. And yes, that gives me a 3. So this can actually factor one more step. So that 3x minus 5 just gets written down for the next line. And then we are going to factor out 4x squared minus 9. And this is the difference of squares, so it's 2x minus 3 and 2x plus 3. And that is my final answer. So the reason I was able to go one more step is that squared quadratic, or the squared binomial that we had, can be is a difference of squares, so we can actually factor it by the difference of squares rule. So the only rules that can factor out a binomial that you have right now is difference of squares or the sum or difference of cubes. So watch for those as you're looking at the rules.